Imagine a world where your cracked smartphone screen repairs itself, or a car that fixes its own dents and scratches. Sounds like science fiction, right? Well, buckle up, because we're about to embark on a journey into the fascinating realm of self-healing materials. This isn't just the stuff of movies anymore, it's happening right now, in labs across the globe. Self-healing materials are set to change the game. They're not just cool, they're practical, efficient, and could solve some of our biggest problems. Think about it. How many times have you dropped your phone or scratched your car? What if those damages could fix themselves? In a world grappling with waste and environmental issues, self-healing materials offer hope. They could extend the life of products, reduce waste, and decrease our reliance on replacements. So, what exactly are self-healing materials? In the simplest terms, they're materials that can repair damage to themselves without any external intervention. It's like giving a material its own first aid kit. When it gets damaged, it automatically starts the healing process. No need for human help or complicated repair procedures. These materials come in many forms. Some use capsules filled with healing agents. When the material cracks, these capsules break open. The healing agent flows out and fills the crack. Others use a vascular system like blood vessels in our body. This system continuously circulates the healing agent. The key to all these methods is autonomy. The material doesn't need us to tell it to heal. It does it all on its own. You might be thinking, this all sounds great, but is it real? The answer is a resounding yes. Self-healing materials are already being used in various applications. Let's take a look at some real-world examples. First up, we have self-healing concrete. It uses bacteria that activate when water seeps into cracks, producing limestone to seal the crack. This could revolutionize construction, making buildings and bridges more durable and safer. Next, we have self-healing coatings for cars and smartphones. When the coating gets scratched, it can repair itself. Some car manufacturers are already using this technology. In electronics, self-healing batteries and circuits could lead to longer-lasting devices and reduce electronic waste. It's a game-changer for our increasingly tech-dependent world. Now let's dive a bit deeper into the science. How do these materials actually work? It's not magic, even though it might seem like it. It's all about clever chemistry and engineering. One common method uses microcapsules filled with a healing agent. They're mixed into the material during production. When the material cracks, so do the capsules. The healing agent spills out and fills the crack, then hardens, sealing the damage. Another approach uses a vascular system inspired by our own bodies. These materials have channels filled with healing agents. When damage occurs, the agents flow to the site and repair the damage. Some self-healing materials use reversible chemical bonds. When the material breaks, these bonds can reform. This method is particularly useful for materials that need to be flexible. It's like having a bunch of tiny magnets that can reconnect after being pulled apart. Now let's gaze into our crystal ball. What does the future hold for self-healing materials? The possibilities are truly mind-boggling. Imagine self-healing solar panels that repair damage from harsh weather or debris. They'd last longer and be more efficient, making renewable energy even more viable. Or how about self-healing spacesuits? In the harsh environment of space, any damage could be fatal. Self-healing materials could provide an extra layer of safety for astronauts. Back on Earth, we might see self-healing roads that repair potholes on their own. No more dodging holes or waiting for road crews. This could save billions in maintenance costs and make our roads safer. The next few decades could bring some incredible advancements. Of course, with any new technology, there are challenges to overcome. Self-healing materials are no exception. We need to consider the potential drawbacks and ethical implications. One challenge is cost. Right now, self-healing materials are expensive to produce. This limits their widespread use. We need to find ways to make them more affordable. Another issue is durability. While these materials can heal themselves, they may not be as strong as traditional materials. We need to ensure they can withstand real-world conditions. There are also ethical considerations. Could self-healing materials lead to more disposable products? We need to ensure this technology promotes sustainability, not wastefulness. As we wrap up our journey through the world of self-healing materials, let's take a moment to imagine the future. Picture a world where our possessions last longer, where our infrastructure is more resilient, where we produce less waste and live more sustainably. This isn't just a pipe dream, it's a future we're actively working towards. Self-healing materials are just one piece of the puzzle. They represent a shift in how we think about materials. We're moving from passive to active, from static to dynamic. The potential impact is enormous. We could see reductions in waste, in energy use, in maintenance costs. We could build safer structures, create more durable products, and explore new frontiers. The ripple effects could touch every aspect of our lives. The self-healing revolution is just beginning.